Welcome back to another episode of the React Native Radio Podcast. Episode 310, Nitro Modules with Marc Rousavy.
Hey everyone, welcome to another episode of React Native Radio. We have a real cool episode lined up for you today. Robin and I have a cool guest. I'll get to our guest in a little bit. I'm Mazen Chami, and I live in Durham, North Carolina with my wife and toddler. I'm a former pro soccer player and coach and a senior React Native engineer here at Infinite Red. My co-host, Robin Heinze. Robin is the director of engineering at Infinite Red. She's located west of Portland, Oregon with her husband and 2 kids and has specialized in React Native for the past 7 years. How are you doing, Robin?
I'm doing good. I'm just getting over COVID, so I'm glad that's over.
Yeah. Oh, I hear you. I'm still some long COVID symptoms over here for sure. And our guest, who needs no introduction, is Marc Rousavy. Marc is an Austrian full-stack developer who excels in mobile apps, low-level languages, and GPU-based code. He has a keen UI UX design sense and expertise in C++, Swift, Kotlin, and React Native. As the creator and maintainer of popular open source libraries and CEO of high-end app development agency, Margello, he collaborates with high-profile clients and occasionally tackles intriguing contracts himself. Marc, welcome to the show. How are you doing?
Hey, I'm good. Thanks for having me.
Yeah, of course. We're always happy to have you on here. Before we get into the topic, let's hear from our sponsor. Infinite Red is a premier React Native consultancy fully located remote in the United States. We're a team of 30 senior plus level React Native developers and support staff and have been doing React Native for nearly a decade. If you're looking for React Native expertise for your next project, hit us up at infinite.red/React Native. Don't forget to mention that you heard us through the React Native Radio podcast. All right, let's get into our topic. We're going to be talking about a topic called Nitro, who, if you follow Marc on Twitter, X, whatever they call it these days, you'll know what we're talking about. But luckily we have Marc on here to give us a little more in-depth thoughts on it. So Marc, before we get started with the show, I know you were on with React Native Radio 269 where we talked about Vision Camera V3. But tell us a little bit about yourself and how you got to where you're at.
That's an interesting question. I've always been really interested in app development and, cameras and GPU-based stuff. And it's always fun to play around with those things. So, yeah, I just built stuff. And then at some point I published stuff. And then, that's how Vision Camera got created. And then same story about, React Native MMKV and now also Nitro.
That's awesome. Well, okay. What is, maybe your elevator pitch, what is Nitro Modules?
The fun thing is that this is the first time that I'm actually talking about this, and I actually never gave an elevator pitch about Nitro Modules before, so I don't even know how
so
to
this is
how
your
to
chance.
phrase it.
You're going to workshop it live
chance,
on
right.
React Native Radio.
Yeah, exactly.
We just walked into an elevator.
Yeah.
Hey, Marc. How are you? What are you working on these days?
I'm working on insanely fast C++, Swift, or Kotlin modules that are bridged to JavaScript using Nitro. And I'm building the framework for the foundation to build the bridge, essentially. It's funny because it's, everybody knows what turbo modules are and everybody knows what native modules are. And then also everybody knows what Expo modules are. But, I don't think anyone ever expected there to be, a new library or a new way of doing things anytime soon. I mean, Expo was the answer to, or Expo modules was the answer to, not having Swift or to turbo modules being too complicated. So that's why Expo modules got built, and it did a very good job at that. So Expo modules is really cool. The syntax is amazing. It's very easy to use. But for me, I just always had so there's some limitations, in turbo modules and Expo modules that you can only work around with if you just use the bare JSI layer, right? So the JavaScript interface, if you just use the whole library from C++, and if you do everything yourself, then you can build it. but Turbo Modules and Expo Modules just don't provide APIs for some edge cases. One of those edge cases is Vision Camera's frame processing feature, which is something that I talked about in a previous podcast here. So the way frame processors work is I have a Swift component, which is just a normal, native module or a native view component. And then to actually send the frame over to JavaScript as efficiently as possible, you remember the frame is like a 10 megabyte buffer and we cannot copy it over the bridge or not even with Turbo Modules. So we needed a way to expose a complex C++ type, or in this case a Swift type, to JavaScript and provide some APIs around it, like, getting the frames width and frames height. And we cannot just wrap it in an interface because an interface is just like a normal JSON type, right? So this is the main reason I built Nitro Modules. And then there's many other benefits of Nitro Modules that I'm excited to show you guys and talk about. And one of those is also the improved performance, which was not the main goal with Nitro Modules. I didn't want to just build something faster. It was more about limitations.
So we'll get to the speed part. But one part that I really like about Nitro is you're using Swift. I just did the workshop at Chain React, and it was mainly around Turbo Modules. It was great, but every single step of the way, I kept getting questions like, when can we use Swift? Why aren't we using Swift? Why are we still in Objective-C? Why are we, writing this one line of C++ to tell Objective-C to compile down to C++ and all that kind of stuff? And I got to show the class Swift and C++ side by side, and Swift is just a more modern language, I guess is the best way to put it. And it's much cleaner and easier to read, just kind of like looking at the code versus Objective-C. So I'm excited that we finally have access to Swift. I wonder if Turbo Modules will get there at some point, but not at the point of this recording.
Yeah, that's also the cool thing about Nitro, because I built it mainly for Vision Camera, and Vision Camera is just a Swift library. And Nitro Modules actually doesn't even go through Objective-C at all, because, conventionally you would go through Objective-C as an Objective-C bridging layer and then call into Swift using like the add Objective-C annotations and then the NS number types and NS error and all those kinds of things. But Nitro Modules doesn't do any of that. Nitro Modules actually uses the new Swift, 5.10, something like that. It was just released a few months ago. The new Swift C++ interop, which is like a direct layer between Swift and C++. So you can use some SCD types like SCD string, SCD optional. You can expose any non-templated type to Swift and directly call it, which is simpler and much, much faster. Like insane speeds. It's insane. You don't have to go through Objective-C at all.
That's awesome.
You've talked about like why, like the advantages of Nitro Modules over Turbo Modules and why you built this and what problems it's solving. But like, because like Turbo Modules are sort of like meta's thing. They're blessed by meta, which is obviously like React Native is meta. Are there any disadvantages to going with something that's not like meta's thing? Like, if that makes sense.
Yeah, of course. I mean, I would prefer to have Nitro inside React Native Core, or at least the concepts that I built. But there's a few problems around that. And I mean, Turbo Modules are like the Objective-C and Java Turbo Modules don't create any new, groundbreaking new API design changes, because that would break backwards compatibility. So that's one reason why Turbo Modules aren't the same thing as Nitro Modules now. And also the reason why we can't bring Nitro Modules into React Native Core as of today. I also don't think Facebook wants, or Meta wants to, have a second option for building native components. They have Turbo Modules. They don't want to introduce a second option. And we can't really make Nitro Modules backwards compatible right now. There's a few reasons for that. But I think the main one being that it just has a strong requirement on React Native 0.75 or 74. And I'm not sure if Meta really wants to ship that right now. And also all, existing modules need to be rewritten in Nitro Modules if they want to use the new APIs. And the last point, as far as I know, Meta doesn't use Swift internally. So that's a blocker.
Yeah.
I'm not sure. I think I heard it somewhere, but yeah.
So could you see, like, realistically, like when the new architecture is broadly adopted and people have basically moved on and aren't using the old architecture anymore, can you kind of see Nitro Modules being the standard that most people use, even though it's not included with React Native Core.
Yeah, I can definitely see React Native Nitro being a very good alternative to Turbo or Expo modules. And I just noticed that I didn't even answer your question before. So I'm going to do that now, my bad. Yes, there are disadvantages. The main disadvantage right now is that you have to build the library as a library author from scratch again in Nitro modules.
Yeah.
So, I mean, that's only the bindings, right? So, for example, for Vision Camera, I don't have to write the whole camera stuff again. I just have to write the bindings to JavaScript again, which is take photo, start recording, all those kinds of external bindings, which is not a lot of effort. But for some people, and especially in Vision Camera, because I have this whole like C++ layer where I use some fancy tricks to get the frame exposed to JavaScript, I need to rewrite the whole thing with Nitro, which is going to be much less code, much faster, much easier to maintain, but it's still going to be a rewrite. And second, I mean, every user of a library that is built with Nitro needs to install Nitro modules. I don't know if that's a big problem, but it's an extra step,
Yeah, it is.
Who need to install it.
It is a thing. Yeah.
Mm-hmm. Yeah.
So you've said on Twitter, people were asking you a lot about it, and you said it's object oriented, which speaks to my brain because I'm a Ruby dev at heart. Can you talk about how this is different from the normal ways of writing native modules and why you chose to go sort of object oriented in your approach?
So previously in Turbo modules, native modules, way back in the day, everything was just like very simple. So you had one method exposed to JavaScript, which is in Objective-C, which you could call, and that's it, right? So Facebook or Meta just decided to keep this layer very simple and then do more stuff on the native side or more stuff on the JavaScript side. But communication in between is expensive anyways, and it was just kept at a minimum. So traditionally and still today, in a Turbo module, everything, like every module under quotes, is just a singleton in your app, which has static methods, kind of. It's not a literal static method on the native side, but it feels like a static method on JavaScript, which means you can't really do stuff like passing around instances of some complex type. That's what object-oriented programming is about, right? You have essentially deep down you have, and in C, for example, in the C language, you have struct with state and methods, which is essentially what an object is. And you cannot really represent that in Turbo modules, right? So, for example, one very good example I always talk about is the UI image complex object on iOS, which just holds image data. So you have either like in-memory image, it might just be a large byte array, might also be backed with a GPU texture, it's just maybe it's a system image, whatever it is, it's just a handle you can use to access image data, pass it around, set it on an image component, read back, modify it in memory, and all those kinds of things. And you can't really represent that in a Turbo module, because Turbo modules have a fixed type of, or a number of types they support, which is like, a number, a string, an array, a boolean, and a dictionary as well. And then I guess promise and callback. But you can't really create a complex type per se. And this is what Nitro modules are all about. Every native type you write, which is declared as a TypeScript interface, actually represents an instantiable type on the native side. So you can create instances of whatever type you create. For example, if I write an image component, everything is called a hybrid object. That's how Nitro modules work. So if I create an image hybrid object, then it would be like hybrid image on the native side, and I can create it with a UI image, with a CG image, whatever it is, and I have instances of this type which I can pass around, without copying any bytes in memory. So this is what object-oriented means in this concept, and having first-class support for that is really awesome, because imagine a situation where your camera library of choice, hopefully Vision Camera, is built with Nitro.
Always.
Your image component library of choice is built with Nitro, and your image manipulation library of choice is built with Nitro. Imagine if you return an image from Vision Camera, pass it to your image manipulation library, make it grayscale, crop it, make it bigger, whatever, all of those in memory, and then pass it to your image component. You don't have to do any like file writing, which is what you have to do now, right?
Oh my gosh,
Because
yeah. You'd have to write it to the disk and read it from the disk.
So yeah, you either have to write it to a file and then return the file path, and then if you want to make it grayscale, pass it to your image manipulation library, load it again from the file, write it again to the file. It's a lot of file I/O. Or you use Buffer, which is a semi-implemented API on React Native because it uses a global ID lookup, and the buffer is not really accessible in JavaScript. I think it's called Buffer, yeah. But yeah, it's very inefficient nowadays. So with Nitro modules, it would be more efficient because you can actually pass around instances of the image in memory. And the same goes for like databases. React Native MMKV is one of those instances that has state, native state. So MMKV would be a perfect hybrid object. Image would be a perfect hybrid object. And essentially everything could be a hybrid object. Every native module is a hybrid object. Even if it's just a singleton, you then just have one instance of the hybrid object.
Wow. Like, that's really cool. Like a completely new way of approaching all this stuff. And your example about using it for the whole like image life cycle in an app is really exciting.
Mm-hmm. Yeah, that to me is just mind blowing because you don't have to manually write the JSI bindings anymore, build it. And like you said, step 1, 2, 3, 4, 5, 6, like all that kind of goes away. And that's great. And you posted a tweet eventually got to this whole talk about, you don't have to write the manual JSI bindings anymore. And I just want to talk about the numbers real quick. You have a function for add numbers, and you did it in Expo module, Turbo module, and Nitro module. Nitro module was 59 times faster than Expo modules and 15 times faster than Turbo modules. That's insane to me. I think just let me put that in milliseconds for our listener. Expo module took 435 milliseconds. Okay.
To add some context, we called the function I think 100,000 times, right? Yeah.
100,000 times. Yes. Yeah. Sorry. Function was called 100,000 times.
Yeah.
That's actually very good context.
That would be a long time for calling it once.
I was going to say, let's change. Let's go back a little bit. We called add numbers 100,000 times. That's a lot. Expo modules took 435 milliseconds. Turbo module took 116 milliseconds. Okay, you're like, all right, cool. I'm going to use turbo modules moving forward. But then Nitro comes in to the chat and says, all right, I'm going to do this in 7.3 milliseconds. That's incredible. That's like a huge number change. Mm-hmm. That's mind blowing to me. And, great job. I'm like kind of speechless here and I'm kind of almost reading from a script. Amazing work on that. I want to go into more of like the generation part of Nitro and like how it does its generation. I think for our listeners that are familiar with turbo modules and code gen and kind of the whole JSI new architecture, I think Meta likes to call it the new architecture framework, right? With Nitro, you have a cool generator called Nitrogen. I love that name.
Thank you.
It generates C++.
I just put that together.
Yeah, there you go. So this Nitrogen code generator generates C++ from TypeScript, then a Swift file, eventually Kotlin. You said eventually Kotlin. Is that because you're not at the Android stage, or was that just you have Android so far?
That's why we moved the podcast recording today 1 hour back, because I just, finished like probably 70% of Android already. So I'm almost done with Android as well, yeah.
There you go. Listeners, you heard it here. Mark does not sleep. Anyways. So Nitrogen also auto-generates many C++ Swift bindings that would otherwise be a lot of effort in your native Swift app. So we talked about that. Can you kind of talk about Nitrogen in like aspects of it that we haven't talked about yet? Like how these bindings kind of work and talk to each other, right?
So yeah, the whole architecture is pretty cool actually to talk about. Nitrogen. So let's go through it from the step, like the first step that you write as a library author, as a user of Nitro modules, to actually the last step of what gets executed by the JS runtime. So the beginning is you create your Nitro module, which is just a React Native library. Install React Native Nitro Modules core or React Native Nitro Modules or whatever it's called. And then also install Nitrogen as a code generator. So that's step 0, right? Step 1 is you write your native components like a specification. Similar to how CodeGen works, you create a TypeScript file. And, Nitrogen is all about TypeScript, so there's no flow integration or anything. You create your TypeScript file. It has to have a .nitro.ts suffix. And then in the Nitro file, you export, or you don't even need to export it. You just create your interfaces, which extend hybrid object. And yeah.
So for context for our listeners, like this is the equivalent of a, spec.tsx file that you would do with turbo modules, correct?
Yeah.
Your nitro.ts file.
Yeah. I'm not sure if turbo modules require .spec, do they?
Not .spec. It's like the suffix is usually spec .tsx. It's in a spec folder, spec TS. Yeah.
Yeah, it's essentially I can also parse every TypeScript file because the hard requirement is just that it has to be an interface which extends hybrid object. But I just, thought it would be cleaner to have a .nitro.ts extension. There's no reason behind it. Also, I have to parse less files, I guess. So we have our .nitro.ts file. Let's call it image. Let's go with the image component. We have image.nitro.ts inside image. Inside the TypeScript file, we export an interface called image. And image has to extend hybrid object. And then hybrid object has a generic parameter in which you can just configure the languages you want to use. So by default, it will generate C++ for both platforms, which is just a shared C++ layer. The shared C++ layer always gets generated, even if you bridge to Swift or to Kotlin. It's just one C++ abstract class, which represents the image from TypeScript in C++. You can also, and here's the really cool part, if you generate one part in Swift or in Kotlin or whatever you want in any language, you can still use it from C++ as if it would be just a normal C++ class, because essentially everything's derived from that base C++ class. So this is one of the use cases we needed for React Native Filament, where we had just like 3 platform-specific files, and the rest would all be cross-platform C++. We can now use those 3 platform-specific files, which have a Swift or Kotlin implementation, directly from C++, and it's just a virtual method, so you can just call it like any other C++ method. So basic inheritance, even as a library author, you can work with inheritance here. Okay, let's take a step back here. We want to create our image hybrid object. Inside the image interface in TypeScript, we have properties. So it's either a property or a method. You can add properties and methods, and a property can also be read-only, in which case it only has a getter and not a setter. The image hybrid object will get generated on C++, and if we also specify the target for iOS, for example, in the hybrid object extend clause in TypeScript, you can just specify iOS : like Swift, and then Android : Kotlin, for example. Then it will additionally also create the bindings for Kotlin and Swift. This is the cool thing about the Swift interop. We can bridge directly to Swift, meaning we can use C++ types directly in Swift. It sounds amazing, but it's actually really, really complicated because we need to specialize all templates. And if you're a C++ developer, you know what that means. You have to basically every generic, on the quotes, in C++ needs to be flattened out to not be a generic anymore, because generics cannot be used in Swift, and because templates are a C++ only thing. So we need to generate a lot of additional binding code, to bridge from C++ to Swift, but Nitrogen handles all of that. So for example, for, let's say, an optional with generic parameters of like string, for example, an optional string would have to be flattened out, and it's called optional underscore std string in Swift. So there's a lot of additional code that needs to be generated, but it's all, just to flatten out the template. There's no like overhead of this bridging at all. Like it's just direct C++ calls. But yeah, anyways, so you generated your specs, and the only thing you need to do is implement the interfaces on the native side. So in Swift, it's called protocol. You just implement a protocol, and I try to keep it very similar to how it works in TypeScript. So for example, in Swift, we can use properties, with getters and setters, which are bridged to C++ as get something and set something, just normal functions, because C++ does not have properties. So in Swift, you can use properties, which looks exactly like in TypeScript. You use the normal, the standard Swift types. So for example, you also use like a dictionary or something like that. And then also it supports like a ton of different standard Swift and Kotlin types. So for example, for number, we get a double, for Boolean, a bool, for string, a string, just the normal types that we, all love and know. And then also there's like arrays, as you know. But the cool thing is Nitro also supports variants. So for example, like the pipe operator, right, in TypeScript. So it's either a number or a string. Nitrogen also supports tuples. So, fixed length arrays, which are even size checked when passing them between JS and native. Dictionary, typed dictionaries actually with a fixed type, optionals, promises, obviously, everybody uses promises. And then also array buffer and functions or callbacks actually, which are treated like there's no events anymore in Nitro. You don't have events or like completion or like success or failure listeners. Everything is just either a callback, which you can hold onto, or a synchronous function. And you can pass as many callbacks as you want. It's just like a JavaScript object. So events would be implemented by just, creating a native list of functions and then just adding listeners through Nitro. So there's no event emitters anymore. And then, array buffers and just other hybrid objects. So that's the whole object-oriented part. You can pass a image to an image or return an image from an image. Like you can pass it around inside Nitro modules. And it's all built on the, on the interface level. So you can have different implementations of image as well. If you have like a UI image, which uses UI image on iOS, or CG image, which is the core graphic image implementation, so GPU-based image. But you can pass it around as just any image. So that's the object-oriented part of this as well.
That's awesome. Yeah, I'm going to put in the show notes your tweet that has the full list of all these C++ JS types mapping. So that'll be available to our listeners.
Perfect.
We're unfortunately getting to the end of the time that we have, but this has all been incredible information. I want to wrap up talking to our audience briefly, who a lot of them are probably app developers, maybe some library authors, I'm not sure. But can you talk a bit about like what app developers should expect to need to do in order to get the benefits of Nitro? Like, primarily, I think your audience is library authors. But if I'm like a regular app developer, what do I need to do to leverage these speeds? Is it really just like waiting until my favorite libraries are using Nitro and then installing them? Or is there anything the app developer should know about Nitro and using Nitro?
So the goal of Nitro is to make library development easier and faster for everyone. So my long-term goal is to make just like the entire, library ecosystem in React Native faster and, to provide better libraries. And I already have like a lot of, popular libraries on board with the idea. So that's Jakub from React Native Unistyles. That's Krzysztof from React Native Video, a lot of popular libraries, as well as my libraries, Vision Camera, MMKV, Filament, all of those things. So app developers will get those performance gains for free. And also if they, want to build their own native modules, it should be really, really simple to do so with Nitro, because they can just, run Nitrogen themselves on a native app and then just write their native components and just register them manually in their app delegate. And that's it. So it's very, very easy to add to write a library with Nitro. And if you want to do so yourself, then, it's all open source. There's going to be documentation and everything.
Yeah, it sounds like you're really, really focused on developer experience and making things as pain-free as possible. So that's great.
Exactly.
When will Nitro be ready and available to the public? It's possible it will be by the time this is released. So
yeah. So as of today, when we're recording this, that's August 20th, the C++ code base of Nitro is already completely finished. So everything is already running in production in React Native Filament, which uses an early version of React Native Nitro. And the Swift implementation is also pretty much finished. Jakub is actually experimenting with that right now for React Native Unistyles, and it seems to work very, very good. There's only 2 components which are not bridged to Swift yet, but I consider them low priority for now. And then Kotlin is also like 70% finished. So I think the next steps would be for next week to battle test the whole thing, and then maybe we can have Nitro modules in 2 weeks.
Nice. So that will probably mean that Nitro will be out by the time you're listening to this, and we'll make sure everything you need to know is in the show notes, so you can try it out yourself.
Marc, thank you very much for coming on and talking to us about Nitro. And I'm really excited to see where this goes and how, library maintainers can leverage these incredible speeds and continue to grow the React Native ecosystem and continue to grow React Native in general.
Every time you make a React Native app faster, you help the community, and you help it sort of gain ground against the naysayers.
Exactly. Thank you so much for all your hard work, Marc.
Thank you.
So as we're wrapping up, Robin, do you have a mom joke for us?
I do. I had a lot to choose from this time. We've had lots of activity in the jokes channel and Slack. But this is my favorite. What do you call a reluctant potato?
What?
A hesitator. It's so dumb, but it's so funny.
It is.
So you have a dedicated joke channel?
We do have a jokes channel, yeah.
We do.
Damn. Now I'm jealous.
Create one for us, Marc, and we'll put some jokes in there for you in your Discord.
Yeah.
Awesome. Well, thank you both, and to our listeners, see you all next time.
Bye.
Bye.
As always, thanks to our editor, Todd Worth. Our assistant editor, this guy, Jed Bartosky. Our marketing and episode release coordinator, Justin Husky. And our guest coordinator, Mazen Chami. Our producers and hosts are Jamin Holmgren, Robin Heinze, and Mazen Chami. Thanks to our sponsor, Infinite Red. Check us out at infinite.red/radio. A special thanks to all of you listening today. Make sure to subscribe to React Native Radio on all the major podcasting platforms.